Hello everyone, I'm Wenjun Yuan from the Robotic Institute, Carnegie Mellon University. Today, I would like to talk about the research in touch sensing for robots. Here is a typical example of the tactile sensors people have been widely used. The aim of this kind of sensor is to measure the distribution of the contact force. Another kind of sensors that have been used to measure touch is the force torque sensors that are installed either on the wrist or near the fingertips of the robot hands so that they can measure the load within the hand. For robots, there are two typical applications for touch sensing. One is manipulation, one is exploration. That means to understand the objects in physics. This is an example of manipulation. The robot is grasping a cup and adjusting the force according to the tactile feedback so that the force is not too large to damage the objects, nor too small. To use tactile feedback to servo. So the other part of use of tactile sensors is how to help robots to understand the world and explore the objects. So for example, people have been making the robots to touch the objects. For example, here is a mug, and by using the tactile sensor arrays that attach the fingertip, the robot can get some general geometry information about the objects, and that can be used to recognize which object it is. In another example, the robot is able to recognizing the materials when sliding on the surface because different materials will generate different vibration patterns during the slide. So here we may wonder, how does it work for human to feel the touch? So here I'm showing the mechanical receptors in our skin to help us to feel touch. So in short, we're using 4 different kinds of mechanical receptors to feel touch. So uh, they have different properties, and they're designed to detect signals either in a small range with higher spatial resolution or in a larger range with a much lower spatial resolution. And they are also sensitive to either low frequency contact or high frequency contact. And also, apart from those mechanical receptors on the skin, we also use other organs to help us to feel touch, especially the muscles, which can tell us about the load on the muscles, and that indicates what's the load on each joints. So the lesson from human is that we want to use a system to detect touch instead of using a single kind of sensor or a single kind of mechanical receptors. So people also propose we can make a similar system for robots as well. So another interesting lesson we learn from human is that humans touch sensing is also combined with motion. So for example, this theory proposed in 1980s about exploratory procedure, saying that humans actually have different kind of motion procedures as a goal of perceiving different property of touch. And the understanding we have about the objects is a combination of the motion and the tactile signals we get from our skins and other mechanical receptors. So let's come back to the robots. So as we have learned what has happened in the field, and so where should the community go for the next step? So definitely we want to make a good tactile sensing system. So that means making good sensors, but also they integrate multiple sensors, single grippers. And apart from that, we also want to find a way to combine the system of touch sensing with other parts of the robots, such as the motion, the visual input, and the audio input. Apart from that, we also want to go dexterous. So we take the example of humans. We use our hand to move very dexterously when we try to touch the objects. And it's the same thing for robots. It's good if we can find some way to make the tactile sensors working together with the dexterous structures of the robots so that we can perform very complicated and flexible movements when exploring different objects or conducting complicated tasks. So that's the end of my talk. Thank you. To achieve some complicated manipulation tasks.